Okay. In the last class, what we discussed?
Auto cycle.
Auto cycle. Got it. So, what is an auto cycle? Auto cycle is a constant volume heat addition cycle. So, the processes we discussed, what are the processes in auto cycle, which is mainly used in spark ignition engine or petrol engine, and the efficiency we got 1 minus 1 by RC to the power gamma. Now, what is this RC? RC ki vastu? Compression ratio. Compression ratio. Huh? You always say compression ratio. Now, RC is equal to what? From this diagram, we can say V1 by V2, and that is equal to Vc plus Vs divided by Vc. And this we discussed in the previous class. Okay. Now, also we discussed that the efficiency of auto cycle depends on what? RC. If RC is more, then the efficiency will be more. If RC is less, efficiency of auto cycle will be less. Let's see how the RC, value of RC, okay, what is value of RC determines the efficiency of auto cycle. Okay, this is the formula, eta equal to 1 minus 1 by RC to the power gamma minus 1. Gamma is the ratio of Cp and Cv. You see, if compression ratio is 2, then efficiency of auto cycle is 24.51. If we increase the compression ratio to 3, then efficiency will increase to 35.42. If we increase the compression ratio to 4, then efficiency will be 42.56. If it is 4.5, then it is this much. This way, if we increase the compression ratio RC, this is compression ratio RC, and this is the efficiency. So, if the compression ratio is 7, the efficiency is 54. Just you try to understand. Now, if we increase the compression ratio to 8, there is not much increase in efficiency. Slight increase in efficiency we can get, that is 2.46. Okay. So, generally auto cycle utilizes efficiency from 6 to 8, generally 7. This is most suitable compression ratio for auto cycle, that means spark ignition engine, that means whatever engine you use in motorcycles, because all motorcycles are petrol engine. So, petrol engine, in that case the compression ratio will be from 6 to 8. In that range we generally get the compression ratio. Sometimes it may go to 9, 10, but this is the most common, 7, 7.5, 8. All petrol engines, okay? It may be car also, it may be bike, but the engine is petrol engine or spark ignition engine, because there is one spark plug in the petrol engine. That is why it is called spark ignition engine. Now, if we draw a curve between compression ratio and efficiency in two axes, that is x and y axis, then we will get a curve like this. So, the axes are what? This is the y-axis, say this is x-axis, that means x-axis is now compression ratio and y-axis is now efficiency. You can observe in the curve that it is going this way and it will not increase enough after. If we increase the compression ratio, we will not get too much improvement in the efficiency. And more than that, if we increase the compression ratio beyond this, beyond say 9 or 10, there are many other problems in the running the spark ignition engine. So, because of the practical difficulties, the compression ratio of petrol engine, which utilizes the Otto cycle, is between say 6 to 8 or 9. And we also discussed how the compression ratio affects on the efficiency of the engine. Okay. Now today we will discuss diesel cycle, and which is called constant pressure cycle. The previous one was constant volume cycle, and this is constant pressure cycle. That means the heat addition will be done at constant pressure, and that is why it is called constant pressure heat addition cycle. Let's see how we can understand this thing. So before going to the details of the processes, there are some assumptions as usual. In the last class also we discussed the assumptions. First one is the working fluid and specific heats are what? Working fluid is air, that is the assumption, and another is specific heat Cp and Cv remain constant throughout the cycle. The air is compressed and expanded adiabatically without any friction in the engine cylinder. So all compression and expansion processes are isentropic. Okay, isentropic compression and isentropic expansion. This is same like Otto cycle. Next is heat is supplied. How? What is this? Here is the difference with Otto cycle. Heat is supplied how? At constant pressure. Otto cycle ki paisilo ami heat is supplied at constant volume, but in diesel cycle heat is supplied at constant pressure. And how it is supplied? By bringing a hot body in contact with the cylinder. How adiabatic process is carried out? By bringing one insulator in contact with the cylinder so that heat interaction cannot take place. Similarly, heat supplied and heat rejected are same. Heat is rejected at constant volume, but this is same with Otto cycle. Okay, heat is rejected at constant volume. How? By bringing a cold body in contact with the end of the cylinder. And how is heat added? By bringing a hot body in contact with the cylinder head. That is same. Assumptions are same. Only difference is heat is supplied at constant pressure. Okay, till now. Any question? Okay, fine. Now let's understand the processes. What are the processes? You tell me from the PV diagram. The first one is diesel cycle PV diagram, and second one is diesel cycle temperature entropy diagram. Now from the diagram, can you tell me about process 1, 2? From first diagram, that is PV diagram. Process 1, 2.
The constant pressure process.
No. Process 1, 2. I am talking about process 1, 2. Diagram to cycle PV diagram. Compression. Aru ki kobo pari. Compression koiso ami volume decrease hoise kimanor pra V1 or pra V2 leke volume decrease hoise. So that is a compression process. Aru kiba kobo pari niki? From this thing. Fantastic. Good. So this is isentropic compression. Fine. Very good. Okay. Next process is process 2, 3. Kick about process 2, 3. What type of process it is? From PV diagram, you look at the PV diagram. Process 2, 3. Upper diagram. You can also see the TS diagram.
Isobaric expansion.
Good. Isobaric. You use the word isobaric. That is good. Fine. Isobaric, that means constant pressure. Isobaric ki?
Expansion.
2, 3. Expansion to koi ami ki koisu? Heat will be added at this time, that is Qs. Okay. So you say expansion নিচিনা লাগিছে যদিও actually this is not, I mean we do not consider it to be expansion, we will call it heat addition. So what is the expansion process? In expansion there will be increase in volume. During process 2-3 volume increases but pressure is not decreasing. So what are the characteristics of an expansion process? Volume increases and pressure decreases. But during the process 2-3, although the volume increases, the pressure remaining constant. So we will call, because why pressure remaining constant? Because during this time heat is added to the system. Somehow heat is added. We assume that we add the heat by bringing a hot body in contact with the cylinder head. Okay, fine. This is isobaric heat addition, or you can say constant pressure heat addition process. Process 3-4. Now come to process 3-4. Now tell me what is process 3-4 from PV diagram?
Isentropic expansion.
Good. Isentropic expansion. Very good. During the process 3-4 it is isentropic expansion. Now next 4-1, process 4-1.
Isoporic heat rejection.
Yeah.
Isoporic heat rejection.
Heat rejection, fantastic. So this is a heat rejection process. মই বেলেগ এটা color use কৰিছো. This is heat rejection process QR, and you can see V equal to C, that means constant volume. So we will call it isochoric or constant volume. Isochoric heat rejection. So this way we have described the processes involved in a diesel cycle. Key difference pala? Only process 2-3, which is isobaric heat addition, but in the Otto cycle it was isochoric heat addition or constant volume heat addition. Now process 1-2 is isentropic compression. That in isentropic compression, is there any heat interaction during this process? Zero. Excellent. So this nature of the adiabatic process is delta Q equal to 0. So we need not find Q12 is how much. There will be what? There will be some work interaction definitely, and that we need not find out. We need not use any formula as of now. Okay. Now come to the process 2-3. In process 2-3, which is isobaric constant pressure heat addition, is there any heat interaction?
Yes.
Good. So heat interaction we will call 2-3. Can you remember the formula for heat interaction during a constant pressure process? Kunobai paribane? Just try kora. Very good. Jodi para. Bahut bhal kotha.
MCV into T2 minus T1.
MCV নহয়, হা? অকমান ভাবা আৰু কোনোবাই ট্ৰাই কৰা। শিৱম পাৰিবা দে কোৱা।
Sir, MCV into T2 minus T1.
Good. Constant pressure process হলে heat interaction MCP হয়। সেইটোৱে ডিফাৰেন্স, বাকি নহলে একো ডিফাৰেন্স নাই। MCP T3 minus T2. Good. Fine. ইয়াত কি হয় হিট এডিশন হৈছে work interaction কিমান হ'ব W23 কিবা আছে নেকি বাৰু? Now come to the isentropic compression process. Isentropic expansion process. Is there any heat interaction? No. But there will be some work interaction that we will call W34, but we need not find out. We can find out, but we are going to reach to a point in which we need not find out directly what is the work output. Now come to the process isochoric heat rejection. Now Shivam, etia kobane kiman? Yato tumar Q41 কিমান শিবম
Sir, CV into T2 minus T1.
গুড why CV এবাৰ কিয় তুমি CV কলা
Sir, volume constant is sir.
volume constant because the process is constant volume process that is why CV good temperature is higher temperature minus lower temperature so yet ami ki palu duta heat transfer hoise and what is a heat engine how heat engine works ami paisilu that it takes heat from a source at temperature T1 it takes Q1 quantity of heat and Q1 we can say Qs also okay then this is heat engine and it rejects some amount of heat and which is QR to a temperature at a temperature lower temperature and the rest is converted to work which we call net work output then that is equal to Qs minus QR so from this formula we can find out the efficiency and what is efficiency W net divided by okay good now so work output work done by the cycle W is equal to Qs minus QR so what is Qs mCp T3 minus T2 and QR is this much that we have already discussed next what are the heat interaction number 1 is heat supplied during the process 2-3 and number 2 is heat rejected during the process 4-1 and there is no any heat interaction during the other two processes process 1-2 and 3-4 because those processes are adiabatic process so during adiabatic process no heat interaction takes place okay so we will proceed with these two heat interactions from which we can find out the net work output as well as the efficiency so here we will find out what is the efficiency of diesel cycle ki hobo diesel is equal to kiman W net divided by Qs and what is W net is equal to what Qs minus QR divided by Qs so that is equal to 1 minus QR divided by Qs so what is QR 1 minus m CV T4 minus T1 and Qs is m CP T3 minus T2 so this is equal to 1 minus m will be cancelled 1 divided by CP divided by CV into T4 minus T1 divided by T3 minus T2 and that is equal to 1 minus 1 by gamma into T4 minus T1 divided by T3 minus T2 okay so this is in terms of temperature what is this efficiency of diesel cycle mane compression ratio ki hobo etu cycle you tell me the compression ratio from what is the ratio from PV diagram so whenever I say compression ratio you think of the process which is compression process in this PV diagram which one is compression process 1-2 so what is the volume before compression V1 good and now what is the volume after compression that's it so compression ratio is equal to V2 nahoy V1 by V2 so this is the compression ratio V1 by V2 for this diesel cycle now you come to expansion ratio
V4 by V3
V4 by V3 very good so expansion ratio is for the expansion process the process is 3-4 volume after expansion divided by volume before expansion. And better to think like this, higher volume divided by lower volume. So what is higher volume? V4. And what is lower volume? V3. So this is RE. But in Otto cycle, both RC was equal to RE. But in diesel cycle, this is not so. This is different ratio. Compression ratio is different from expansion ratio. PV diagram tumi aru eta bostu saba V4 equal to what? V4 V1 hebilako amak dorkar hoba V4 equal to aru eta ratio ase ha aji ami eta notun ratio introduce korisu for you people. That ratio we call, one is compression ratio, another is expansion ratio. There is another ratio that is called cut off ratio, and this is represented by rho. Good. So this symbol is generally it is used, the rho symbol is used to represent cut off ratio. So cut off ratio rho is equal to, from this diagram it is V3 divided by V2. That means volume after heat addition and volume before heat addition. So volume before heat addition kiman V2. Compression or pisot ki hoy process to heat addition, and heat addition begins at point 2 and it ends at point 3. Now during this time from 2 to 3 piston to ki hoy baru olop anuman koribo parisane piston to kor pora koloi jay TDC to BDC. Very good. The piston moves from TDC to BDC. That means when the piston moves from TDC to BDC, this during this time 2 to 3, this is not expansion. This is heat addition. That means out of this total movement, what is the movement? That is called stroke length. During this movement, a part of this movement is used for heat addition. So heat addition begins at point 2 and heat addition is cut off. Heat addition is cut off or stopped. So let me write it. Heat addition is cut off. Cut off mane to janai, everybody know the meaning of cut off at point 3. That is why it is called cut off ratio. When the piston moves from TDC to BDC, at TDC heat addition begins and at point 3 heat addition stopped or cut off. After that what will happen? From when the heat addition is cut off, then the expansion will begin. So that is why this ratio is a special ratio that is called V3 divided by V2. Now you see RC into RE. What is this? RC kiman? Let me write it like this. RC divided by RE. So RC you have said V1 divided by V2. Now what is RE? Compression ratio?
V4 divided by V2.
V4 divided by V2. Take ami ki likhibo paru? V1 by V2 into V3 divided by V4. Now we can write V1 into V4, V3 divided by V4 equal to V1. All of agate tumaloge ajane kola. So V1 cancel. Now it is V3 divided by V2. Now what is V3 divided by V2? Cut off ratio. So what we get? RC divided by RE is equal to cut off ratio, or we can say RC is equal to rho RE. Right? So this way we can deduce a formula, okay? And if you go on simplifying the thing, ultimately we will get an equation for efficiency of diesel engine. Na? So what the formulas will use? T2 divided by T1 is equal to V1 by V2 all to the power kiman gamma minus 1 and T2 equal to kiman palu ami T1 RC, very good, RC to the power gamma minus 1. So T2 equal to T1 RC to the power gamma minus 1. Now come to the process 3-4. T3 by T4 equal to kiman V4 by V3 all to the power gamma minus 1. Now V4 by V3 ki vastu? RE to the power gamma minus 1. So we can write T3 is equal to kiman T4 RE to the power gamma minus 1. So process P2 V2 divided by T2 is equal to P3 V3 divided by T3. Eto ki law?
Yes sir.
Ki law eto?
Charge law.
মই যেটো লিখিছো general gas law, but it may be Charles law if P are cancelled. Okay, so from this we get T3 divided by T2 is equal to kiman hobo V3 divided by V2. Now what is V3 divided by V2. Now what is V3 divided by V2? Jyotirmoy Saloy.
Sir,
Ki hobo?
sir, eto cut off ratio sir.
Cut off, very good. This ei metro ami kolo cut off ratio rho. So ami palu T3 divided by T2 gotike T3 equal to ko kiman likhibo paro ami rho T2 likhibo paro. Ete so ami palu T2 equal to T1 eto prothom equation tar pisot ami palu T3 equal to kiman palu rho T2 হয় না গতিকে T2 আকৌ অলপ আগতে T2 পাইছো rho into T2 ঠাইত লিখিব পাৰো T1 RC to the power gamma minus 1. T4. Now T4 equal to কিমান হ'ব? এইটোৰ পৰা আমি কি পাম? T4 equal to কি হ'ব? T3 divided by RE to the power gamma minus 1. অলপ আগতে আমি পাই আহিছো RC by RE কিমান আছিল? RC by RE rho নাই এটো আছিল so RE equal to কিমান? RC divided by rho. So in place of RC we can write RC divided by rho. So RC this is equal to rho. So RE equal to RC divided by rho. গতিকে আমি T4 কি লিখিব পাৰো equal to T3 divided by RE to কি লিখিম RC to the power gamma divided by কিমান হ'ব rho to the power gamma হ'ব হয়নে? So it will be T3 rho to the power gamma divided by
gamma minus 1 হ'ব নেকি sir?
Oh sorry, gamma minus 1 আছিল ন এবিলাকো sorry gamma minus 1 হ'ব rho to the power gamma minus 1 rho to the power gamma minus 1 RC to the power gamma minus 1. Thank you. So আমি T4 কিমান পালো?
P3 rho gamma minus 1 by RC rho gamma.
Good. আকৌ T3 equal to কিমান? আচ্ছা ঠিক আছে T3 ঠাইত আমি কি লিখিব পাৰো এটোৰ পৰা আমি কি লিখিব পাৰো এটা T3 equal to কিমান আছিল rho T1 RC to the power gamma minus 1 into eto rho to the power gamma minus 1 আছে নহয় rho to the power gamma minus 1 তলত তো কিমান আছে RC to the power gamma minus 1 আছে. So a RC to the power gamma minus 1 আৰু এটো নাইকিয়া হ'ব থাকিব কিমান rho into rho to the power gamma minus 1 কি হ'ব গৈ এটো
Rho to the power gamma.
Sir, rho to the power gamma.
rho to the power gamma into T1. So just it is simple mathematics etur pora hitule goi asa, it can be solved any other way. Etia jodi amar original equation ta ami ki paisilo, this is the efficiency hane olop agote je ami kori thoi disilo. Now here you put the values of T4, T1, T3, T2 and then simplify. And if you do that, I give it to you. You try to solve it, putting the values. Finally, what you will get? Efficiency of diesel cycle is 1 by RC to the power gamma minus 1 into rho to the power gamma minus 1 divided by gamma into rho minus 1. That will be the formula for efficiency of diesel cycle. 1 minus 1 by RC to the power gamma into 1 by gamma rho to the power gamma minus 1 divided by rho minus 1. Eto mor likhat bhalo ana hekane tumi p boli koisa. Acha yat jodi tumi swat
RC gamma minus 1.
Gamma minus 1. Thank you. Rabbi, 1 minute. Gamma minus 1. So what is the difference between Otto cycle and diesel cycle? Kiba question thakile by the time you can ask. Unveiled by Nicholas Otto in 1878. Otto cycle kone prothome unveil korisile? Nicholas Otto. Hedina moi koisilu naam to pahorisilo boli, full naam to. He was Nicholas Otto in 1876. And diesel engine kone unveil korisile? Rudolf Diesel. So petrol engine works on principle of Otto. So definitely Otto is the principle. It's a principle. What is a cycle? A cycle is a principle. Now diesel engine works on principle of diesel. Tumalke nabhabiba je cycle is something fitted with the engine. It is only a principle. On what principle the engine works? That is the thing. Heat addition takes place at constant volume. Ami joa dudin takei koi ahisu. Heat is added at constant pressure. Diesel cycle. The overall efficiency is way less than that of a diesel cycle. Diesel cycle at koi petrol cycle or petrol engine or engine no cycle, auto cycle or overall efficiency is less. Less. Adiabatic expansion takes place from TDC to BDC during backward stroke. Moi kosilu nai TDC pora BDC loi goi thakute whole gotei distance to a whole expansion stroke for auto cycle. Kintu এই খিনিৰ ভিতৰত 2 পৰা 3 লৈ এই জায়গাটো হল যদিও টিডিসিৰ পৰা বিডিসি গৈছে during this time no expansion takes place, only that is the heat addition process. That is why cutoff ratio. Adiabatic expansion takes place during backward stroke, but after the heat addition is cut off. That is called cutoff. Compression ratio diesel and petrol engine or kiman 7 or para 10. 7:1 to 10:1, and compression ratio of diesel engine is from 11:1 to 22:1, and that is why diesel engines are very heavy because it has to resist high compression ratio. Diesel engine to material, there are special material so that it can withstand high compression ratio, high thermal efficiency, and comparatively lower thermal efficiency. But this is in a ketia thermal efficiency petrol or besi hoy for same compression ratio. Eke compression ratio lole he petrol engine or efficiency besi hoy, but at higher compression ratio efficiency of diesel engine is more than the petrol engine. That is about engine, but we are talking about diesel cycle. Okay, so there is another cycle, maybe we will discuss in the next class. So till now, if you have any question,